Audio Jungle. Audio Jungle.
So hello friends, my name is Samir Dokadiya and today I will discuss about the hydrogen bond. So hydrogen bond is a one type of intermolecular force. So the definition is the attraction force in which hydrogen atom of one molecule combined with the electronegative atom of the another molecule is known as hydrogen bonding. So let's take an example. Here you can see that this is electronegative atom fluorine. Okay, the fluorine have partial negative charge. Why? Due to these bonding electrons, and the electron cloud of the bond will be more attracted towards the fluorine. So the fluorine have partial negative charge. Okay, so the hydrogen have partial positive charge. Similarly, in the other atom molecule, like this. Okay, so you can see here that the hydrogen atom of the one molecule combined with the electronegative atom of the another molecule. So there will be intermolecular force known as hydrogen bond. Okay, so this is the definition. So here you can see that this hydrogen bond act as a bridge. Why? I am drawing another molecule. Delta minus, delta plus. So you can see that here the hydrogen have a covalent bond with the one electronegative of the molecule, and hydrogen make the hydrogen bond with the electronegative atom of the another molecule. So it acts as a bridge to connect the two electronegative atom in the solution and in the system. Okay, so it is act as a covalent, as a bridge. So what's the cause? Or first of all, we should know that the strength of hydrogen bond. So the strength of hydrogen bond is weaker than the covalent bond. So first of all, we should know that the dissociation energy. Dissociation energy for hydrogen bond is equal to the 40 kilojoule per mole. But for the dissociation energy for the covalent bond, it is equal to the up to the 400 kilojoule per mole. So you can see that the covalent bond have higher strength than the hydrogen bond. Why? Due to this dissociation energy is very high. So you can easily understand that the strength of hydrogen bond is 1/10 of the covalent bond. Okay, so this is the all about the strength of hydrogen bond. Then the cause of hydrogen bond. What is the cause of hydrogen bond? You know that the polarity must be present in the molecule. Why? If the polarity is present in this system or in this molecule, you can see the hydrogen bond. The polarity of the bond, partial negative charge on the negative atom, and partial negative charge will connect with the another molecule of hydrogen and make a hydrogen bond like this. But remember this thing, and you should think about that, the polarity. If the polarity will be higher, if the electronegativity of the atom will be higher, the polarity of will be higher. Okay, polarity of the bond will be higher, more will be the stronger hydrogen bond. Okay, so the polarity is directly proportional to the strength of hydrogen bond. More the polarity of the bond, more will be the negative charge on the electronegative atom, more will be the negative charge, partial negative charge on the electronegative atom, more will be the stronger hydrogen bond. So this is the cause of hydrogen bond. Polarity is the cause of hydrogen bond. So next is the condition for the hydrogen bond. There are two conditions of the hydrogen bond. First is the small size of the electronegative atom. Okay, small size of the atom, and the another is the electronegativity. Both are same thing. Okay, so let's try to do it. Small size of atom. Small size of atom. So the small size of atom is very necessary. You know that in the atom there will be nucleus in the center and there will be electron cloud also. So you know that the center have positive charge. More will be the small size of the atom, more will be the attraction towards the binding electron. More will be the nucleus, more will be the positive charge in the nucleus, more will be the attraction towards the binding electron. And small size of atom have the very small size, and there will be nucleus in the center, and there will be positive charge in the center. This nucleus will attract the valence shell electron and also the binding electron also. Okay, so the small size of atom have the very more attraction towards the binding electron. Okay, so the small size is very necessary. Very small size is very necessary. Why? Because in the nucleus the positive charge attracts the valence electron, and also this small size have the attraction towards the binding electron. Okay, so the more will be the attraction towards the binding electron, more will be the polarity. Why? More will be the attraction towards the binding electron, it will attract the electron cloud towards it, and more will be the partial negative charge, like that. I am giving you the example so you can understand easily. Here is the H and A. You know that there will be nucleus in the center, and it can attract the electron cloud, and it can also attract the binding electron also. So it can attract the binding electron more if the size is very small. If the size is small, okay, size must be small, so it can attract more electrons towards it. So the polarity of the bond will be higher, so that it can have more partial negative charge and it have more partial positive charge. The polarity of the bond will be higher if the size is small. So I can do like the polarity. Okay, small will be the size, more will be the electronegative, and more will be the electronegative, more will be the polarity. So size must be small, so the electronegativity will be higher. Okay, electronegativity higher, polarity of the bond will be also higher. Okay, polarity of the bond will be higher, so the partial negative charge will be also higher. Okay, and doing all of this. Okay, partial negative charge will be higher. So more will be the partial negative charge on this atom, electronegative atom. So the more will be the stronger hydrogen bond. Okay, you can easily understand what I want to say. Okay, so strong hydrogen bond, HB. Okay, strong hydrogen bond. So first of all, size of atom and also electronegativity of the atom. Okay, and so electronegativity both are in this case. Okay, you can see that in the atom there will be nucleus, and this nucleus have attraction towards the electron cloud. Okay, small will be the size, more will be the attraction towards the binding electron. Small will be the size, more will be the attraction towards the binding electron. So the small will be the size, greater the electronegativity, and greater the electronegativity, more will be the polarity of the bond. Why? Greater the electronegativity means the more attraction towards this bonding electron, and bonding electron will be more attracted towards the electronegative atom. So the polarity of the bond will increase. Okay, remember this relationship. Okay, polarity of the bond will increase, partial negative charge will be higher, and the strong hydrogen bond will take place. Okay, so this is the condition of the hydrogen bond. Let's take an example of all type of atoms. Okay, so first of all you should understand and you should know that which type of atoms take place in hydrogen bond, take part in hydrogen bond. So there are nitrogen, oxygen and fluorine are the atoms which take part in making hydrogen bond. Why? There will be smaller size. Okay, you know that there are the nitrogen, oxygen, fluorine are the small size. Okay, and have electronegativity will be higher than their group elements. Okay, than their group elements. This is the group 15, group 16 element, group 17 element. And you also know that it is the first element of group 15, it is the first element of the group 16, and it is fluorine is the first element of group 17. Okay, so the size is small, electronegativity will be higher, and the electronegativity order is fluorine, then oxygen, then nitrogen. This is the electronegativity order. Okay, so this is the condition, and such type of atoms take part in making hydrogen bond. Okay, so the example is, first example I have given you already, that hydrogen fluoride. Okay, so first of all I am taking hydrogen fluoride. So here you can see that one hydrogen fluoride will make two hydrogen bonds. Okay, there will be two hydrogen bonds for one molecule of hydrogen fluoride. So I am only writing that for hydrogen fluoride there will be two hydrogen bond per molecule. But for the H2O, you know that first of all this is the oxygen, this is hydrogen. There will be hydrogen also and oxygen. Okay, here also the hydrogen bond is take place like this. Why? Because this is the delta plus here, delta plus and delta minus here. Delta plus will be also here. So the hydrogen atom of one molecule combined with the electronegative atom of the another molecule is known as hydrogen bond. Here also delta minus. Why? You know that there will be two lone pair. Okay, I am not drawing this. I am only drawing the partial negative charge. So there will be delta minus. Okay, so here also the another is like that. You can see that the hydrogen means the water molecule can make four hydrogen bonds. First is this. First is this, then second, then third, and then fourth. So the water molecule can make four hydrogen bonds. So we can see, we can write that for H2O, there will be four hydrogen bonds per molecule. Remember this thing, it is very important. For NH3, you can write like that. Okay, this is NH3. So in this case, you know that there are hydrogen and there is nitrogen electronegative atom. But there will be another molecule. Okay, there will be another molecule. Okay, one hydrogen atom, so it can make with hydrogen bond with the nitrogen. This is another hydrogen atom, it can make hydrogen bond with the another nitrogen atom. Okay, all hydrogen are covered. So the next is nitrogen. Okay, this nitrogen can make hydrogen bond with the hydrogen of the another ammonia molecule. So you can see clearly that first is this, second, third and fourth. So the one ammonia molecule can make the 4 hydrogen atoms per molecule. Okay, so for NH3, 4 hydrogen bond per molecule. Okay, remember this thing, all of these things. For hydrogen fluoride, 4 hydrogen fluoride, 4 H2O, 4 NH3. Here the 2 hydrogen bond per molecule, 4 hydrogen bond per molecule. Here also 4 hydrogen bond per molecule. Okay, this is the example and the number of hydrogen bonds for all type of molecules. Okay, so the types of hydrogen bond. Next is types of hydrogen bond. But remember this thing, okay? It is very important in the next section, okay? So types of hydrogen bond. First is intramolecular and second is intermolecular hydrogen bond. So the intermolecular and intramolecular both are different things, okay? Intermolecular hydrogen bonds. The definition is the hydrogen atom of one molecule. Hydrogen atom of the one molecule combined with the electronegative atom of the another molecule in the same substance or in same or different substance. Okay, it is known as intermolecular hydrogen bond. Okay, second is intramolecular hydrogen bond. The definition is hydrogen atom of the molecule combined with the electronegative atom in the same molecule is known as intramolecular hydrogen bond. So both are different things. Hydrogen bond, if it occurs in the same molecule, it is known as intramolecular, and if it occurs in the different substance or same substance but molecules are different, okay, so it is known as intermolecular hydrogen bond. So first is types of hydrogen bond. First is intermolecular hydrogen bond. I have already told you that definition is the hydrogen atom of one molecule combined with the electronegative atom of the another molecule in same substance or in different substance. Okay, the same substance or in different substance. So let's take an example. First is in same substance. Okay, it is the same like hydrogen fluoride. Very simple example. Okay, you can see that hydrogen atom of the one molecule combined with the electronegative atom of the another molecule in same substance. It is intermolecular hydrogen, but it is in same substance. But for the different substance, like that, you know that for alcohol, here is the hydrogen atom. It can combine with the electronegative atom of the another molecule. Okay, here you can see the hydrogen atom of the one molecule combined with the electronegative atom of the another molecule, but in different substance. Here is the alcohol and here is the water molecule. So it is also known as intermolecular hydrogen bond. But the difference is it is in the same substance, but it is in the different substance. Okay, I am not drawing the full structure, but it is for the example. Okay, here is delta minus, delta plus, delta plus. There are two examples. Okay, so the intermolecular hydrogen bond will cause an association. Why association? Let's take an example. What is I'm doing? Association of the molecule. Association of the molecule. You can see that clearly that there will be association. Okay, hydrogen fluoride combine with each other. To know clearly, I am taking the example of carboxylic acid. Carboxylic acid in which there will be intermolecular hydrogen bond like that. You can see clearly there will be association. Why? Due to the hydrogen bonding. Okay, the electronegative atom of the another molecule, and this hydrogen is another molecule. Okay, but in the same substance. Okay, so there will be intermolecular hydrogen bond. There are two intermolecular hydrogen bond that makes association in the carboxylic acid. Okay, you can see clearly that it is dimer form. Why? Due to the association, and association is due to the hydrogen bond, intermolecular hydrogen bond. So the association is the result of intermolecular hydrogen bond. There will be another examples like melting point, boiling point, surface tension, viscosity. All type of physical properties also increase. Why? Due to the intermolecular hydrogen bond. I am writing here. Okay. First of all, melting point, boiling point, then viscosity, solubility, and surface tension. Increases due to the intermolecular hydrogen bond. Okay, you know that there will be dissociation, and for association the carboxylic acid will be higher boiling and melting points due to this hydrogen bond, intermolecular hydrogen bond. Melting point increase, boiling point increase, viscosity will be also increase. Okay, solubility also increase. Okay, why? Do you know that in alcohol there will be intermolecular hydrogen bond with the water molecule, so the solubility will increase. Why? If there will be van der Waals force or polar nature of the intermolecular force, solubility will be lower than this alcohol. Then surface tension also increase. So such type of physical property increase due to this intermolecular hydrogen bond. So the result is association, and there is increase in such type of physical properties. So I hope you understand very well about that. Okay. So I am going to the next type, intramolecular hydrogen bond. Intramolecular hydrogen bond. So the definition is hydrogen atom of the molecule combined with the electronegative atom of in the same molecule. Hydrogen atom will combine with the electronegative atom in the same molecule is known as intramolecular hydrogen bond. So the example is orthonitrophenol and orthonitrobenzoic acid. The first is orthonitrophenol. Okay. Here you can see that the electronegative atom of the oxygen. So the hydrogen have partial positive charge and partial negative charge. Here also the partial negative charge on oxygen. Okay. Because nitrogen and then oxygen have more electronegativity. So the hydrogen atom in the molecule combined with the electronegative atom of in the same molecule is known as intramolecular hydrogen bond. So it is the example of orthonitrophenol. Then next is orthonitrobenzoic acid. Okay, the hydrogen atom of the molecule combined with the electronegative atom in the same molecule like that. It is known as intramolecular hydrogen bond. So the example is orthonitrobenzoic acid. Okay, but here there is no association. There will be cyclization. You know that there is this is the cycle. And this is the another cycle. Why? Due to this hydrogen, intramolecular hydrogen bond. So there will be cyclization. and the physical properties like all of the melting point, boiling points are decreased. Why? Due to this intermolecular hydrogen bond. The acidity will also decrease. Why? Let's take an example. Okay, so the cyclization. Okay, but the physical properties in this case decrease. Why? I am taking the example of the acidity. So the orthofluorophenol. Orthofluorophenol. Orthochlorophenol. Orthobromophenols, then orthoiodophenol. So in the first case, you think that the fluorine, chlorine, bromine, iodine, from here to here, electronegativity increase, minus I effect also increase. Okay, so the bond of OH will be more polar. Why? Due to this minus effect of fluorine. Okay, so the hydrogen will easily remove in the solution. So the more acidity will be for orthofluorophenol. You think about that, but you are wrong. Why? The hydrogen bond concept. Okay, the least acidity will be not for our orthoiodophenol but for the orthofluorophenol. Okay, orthofluorophenol. So why? Because here you can see there will be hydrogen bond. Okay, hydrogen bond, intramolecular hydrogen bond. So due to this, it cannot remove easily. Okay, the H plus cannot remove easily. Minus I effect, you know that minus I effect can remove easily H plus, but due to this hydrogen bond, it cannot remove easily in this solution. So the order is first for this I am doing 1 here, then here 2, then this 3 and this 4. So the first is for 2, then 3, then 4 and then 4 1. This is the order. Okay, why? Because chlorine, bromine, iodine is not for the hydrogen bond. They are not come in the hydrogen bond. You should conclude and include the fluorine for the hydrogen bond. So the chlorine, bromine, iodine is the same order like minus I effect. Minus I effect is more for the chlorine, then bromine, then for iodine. So the more acidity will be for chlorine, then for bromine, then for iodine. But due to the hydrogen bonding, it is not come first. It will be very least and at the last. Okay, for the intramolecular hydrogen bond. So the least acidity will be for orthofluorophenol. Okay. Influence on properties of the molecular compound. The first is association. You know that I am giving you. I have given you the example of carboxylic acid. Like in this case, R C double bond O, then OH. Okay, in this case, you know that association is take place. Okay, why? Due to the intermolecular hydrogen bond. Okay, here you can see the intermolecular hydrogen bond take place, and due to these there will be association. So the hydrogen bond influences the properties of this molecule. Why? The association take place, the melting point, boiling point also increase. Okay, but this is the association. But remember the one thing, that the hydrogen bond will be weak when the chain length will be higher. If the chain length will increase, so the hydrogen bond, the weak strength of the hydrogen bond will decrease. I am doing here. Okay, chain length is higher, so the strength will be lower. Strength of hydrogen bond will be lower. Okay, so remember this thing. If the chain length increase, the hydrogen bond will decrease. And you know that in alcohol gas, in the case of alcohol, they make the hydrogen bond with the water molecule. Okay, the solubility will also decrease. We'll discuss in the later stage. But I am here, you know must about that. Okay, the chain length increase, strength of hydrogen bond will decrease. Okay. Then second is melting point and boiling point. Okay, boiling point. So the melting point and boiling point, you know very well about that, for melting point and boiling point. Okay, but this melting point and boiling point increase. Why? Due to the hydrogen bond. You know, in the case of group 15, group 16 and group 17. Okay, NH3 hydrox. Okay, NH3. Then for PH3, then ASH3 arsenic, then SBH3. Okay, this is the group 50. Group 50. Okay, then group 60. Oxygen means OH2O, then H2S, then H2SE, H2TE. Then for group 17, HF, HCl, HBr, and then HI. You know that the hydrogen bond is only occur in the nitrogen, oxygen, and fluorine. Okay, but here what? Here what? You know the intermolecular force occurs in all of the molecule, in all type of molecule. But hydrogen bond will occur in this such type of atom, nitrogen, oxygen, and fluorine. But in this case, phosphorus, arsenic, antimony, sulfur, selenium, tellurium, chlorine, bromine, iodine. What type of bond is occur in this case? Van der Waals force. Van der Waals force. So the Van der Waals force is another thing. Okay, I am giving you the script for Van der Waals force. Van der Waals force is directly proportional. Van der Waals force is directly proportional to the number of electron. Number of electron. The strength of Van der Waals force is directly proportional to the number of electron. The number of electron in atom, in this atom, we have electronegative atom, increase, the Van der Waals force also increase. So the strength of intermolecular bond will also increase. So the strength of intermolecular bond increase, the melting and boiling point increase. Okay, so I am here doing MP and okay, the boiling point also increase. Okay, you know very well about that. The intermolecular force increase, melting point and boiling point increase. Okay, so in this case, Van der Waals force is less stronger than the hydrogen bond. So the very higher melting point and boiling point will be for the NH3, in this case H2O, and then in this case HF. Okay, so I am giving you the order. Okay, and remember this. Okay. So in this case, the first will be strength of hydrogen, melting point and boiling point will be higher in this case for the NH3. Then in this case, PH3, arsenic and antimony. You know that number of electron increase, Van der Waals force increase. So number of electron will be higher for antimony hydride. Okay. So it have more strong Van der Waals force between the two molecules. So the melting point and boiling point will increase in this case. So this Sp. Then for arsenic, then for phosphine. Similarly in this case, in the group 16, here is the group 15, then group 16. First is H2O, then for H2 tellurium, then for selenium, then for H2S. Similarly in this case, group 17, HF, HI, HCl, and then HBr, and then HCl. Here is the order of melting and boiling point. So first here hydrogen bond more stronger, more will be melting and boiling point. But in this case, antimony have more van der Waals force strong, so it will be come next to the ammonia. Similarly, in all of the case. Okay. So here is the melting point and boiling point. So what about that? If I am taking the example NH3, H2O, NHF, what will be the come first in the case of melting and boiling point? So I am already told you that in this case ammonia have 4 hydrogen bond per molecule. H2O have also 4 hydrogen bond per molecule. HF have 2 hydrogen bond per molecule. Okay. So the thing is, the order is, first you should know the number of hydrogen bond, not the electronegativity. If you think about that, the electronegativity will be higher for fluorine, so the melting point or boiling point will be higher for hydrogen chloride. You are wrong. Okay, you know that, you write like that. Okay, HF, then nitrogen, oxygen, and then H2O, then NH3. You are wrong. It is wrong order. The order is, right order is for the melting point and boiling point is first come in the H2O. Okay, then NH3, then HF. Why? The hydrogen bond, number of hydrogen bond per molecule is more in the H2O and NH3 and low in the hydrogen fluoride 2. Okay, in this case 2, in this case 4, in this case 4. It will be lower. Okay, lower boiling point and melting point. So the 2 hydrogen bond, due to this 2 hydrogen bond, it have low melting and boiling point. But in this case 4 and 4, so it will become first. But in this case oxygen have higher electronegativity than the nitrogen, so it will come first, then the ammonia. So the right order is this. Okay, so here is the all about the melting and boiling point. So the next is phase or state of the molecule or compound. Okay, state of the molecule or compound. You know, there are many states of matter. Okay, the common is solid, liquid, and gas. Okay, there are plasma, Bose and condensed state. Okay, many research take place for the state of matter, but the 3 is common: solid, liquid, and gas. So the solid, liquid, and gas, more will be the stronger hydrogen bond, more will be the state of matter will be changed. In the case of H2O and H2S, okay, in this case there will be van der Waals force and it have lower strength than the hydrogen bond, so it will be in the form of gas. Okay, it will be in the form of gas. So and this is in the form of liquid. Okay, you know that solid, liquid, and gas. Solid means why it is exist as a solid form at room temperature. Why? Because the high boiling point at room temperature. High boiling point at room temperature. Okay. For liquid, why it act as a liquid? It have low melting point. Okay. Here is the low melting point. Okay. High melting point. Here is the low melting point and high boiling point. And for gas, have low melting point and low boiling point. So in this case, it is only for state of matter. Okay, it act as a low melting point. Okay, it is no, you know very well about that. It have low melting point but high boiling point. Then the H2S. H2S have low boiling point and H2O have high boiling point. Why? It have hydrogen bond act in the intermolecular level and it have van der Waals force act at the intermolecular level. So it have low boiling point and it have high boiling point. So it acts as a liquid at the room temperature and it acts as a gas at the room temperature. So there is the difference in state of matter in the same group element due to the difference in the intermolecular force. Okay, so here is the third state of matter. Okay, the state of matter. And the fourth is solubility. Solubility. So the solubility of the alcohol. Alcohol makes a hydrogen bond with the water molecule like that. I am not drawing last structure, okay? Here is the intermolecular hydrogen bond in this different substance, so it have more solubility because due to the hydrogen bond, intermolecular hydrogen bond. But remember this thing, I am already told you that the chain length increase, the strength of hydrogen bond will decrease, so the solubility will be decrease. Okay, solubility decrease. So the strength of hydrogen bond is very important for the physical properties. Okay, so here is the solubility of the alcohol. Carbon will also dissolve in the water molecule because in this case also hydrogen bond is there. Okay, like that. Okay, delta minus, delta plus, delta minus and delta plus. Here both cases have solubility, okay, due to the hydrogen bond with the water molecule. Okay, so here's the fourth case. Then fifth case is volatility. Volatility means the at room temperature, the enthalpy of vaporization will be higher for what? More will be the enthalpy of vaporization, low will be the volatility, okay. Volatility. So you know that volatility is directly proportional or inversely proportional to the enthalpy of vaporization. More will be the enthalpy of vaporization, low will be the volatility. Okay, volatility will be inversely proportional to the enthalpy of vaporization. Enthalpy of is higher, so the volatility will be lower. Volatility. Okay, so in this case similar to the melting point and boiling point. Okay, so then in the case of group 15, group 16 and group 17, okay, in the group 15 there will be nitrogen, then phosphorus, arsenic and antimony. Okay, so the enthalpy of vaporization is directly proportional to the strength of the intermolecular bond. More will be the stronger strength of intermolecular bond, low will be the volatility, more will be the enthalpy of vaporization. So the enthalpy of vaporization is inversely proportional to the volatility. So in the case of NH3, then phosphine, arsenic, antimony. Group 15. Okay, in this case the volatility will be higher for what? You know, in this case there will be hydrogen bond. Okay, there will be hydrogen bond, so the volatility will be lower because the hydrogen bond is stronger bond than this van der Waals force. Okay, the enthalpy vaporization is higher for this. Okay, so I am drawing, NH3 is first. Okay, enthalpy of vaporization is higher for NH3 than for what? SbH3, because in this case number of electron is higher, van der Waals force increase. SbH3, then ASH3, then phosphine. It is for the enthalpy. Okay, then the volatility. Volatility will be higher for the phosphine. The contra or this order will be changed. Okay, first is phosphine, then ASH3, then for SbH3, and then for NH3. This is the order of group 15. Then for group 16, what the order of group 16? H2O, H2S, H2, Se, H2, everything. Okay. Enthalpy is similar in the group 15. Okay, similar to the group 15. First is for the H2O. Due to the hydrogen bonding, Then for tellurium, because the van der Waals force higher due to the number of electron is higher, so the van der Waals force also higher. So the H2P is the next. Okay. Then H2 selenium. Then for H2S. It is for the enthalpy, the volatility. First is H2S, then H2SE, tellurium, okay, sulfur, selenium and tellurium, then for H2O. Okay, this will be for the H2O. Okay, here is the order for group 16, then for group 17 there will be different order. HF, HCl, HBr and HI. The first is for enthalpy. HF, then for HI, then for HBr, then for HCl. Okay, it is for the enthalpy, and then for the volatility. First is for HCl, okay, then for HBr, then for HI, and then for HCl, Br, I. So here is the order of volatility. So I hope you understand the concept very well. Okay, this is all about the hydrogen bond, and I hope you understand very well. If you have any query about this topic, so please say me in comment section. I will solve it as fast as possible. Okay, so I hope you understand very well about that. Okay, so thank you so much for watching my video. If you like my video, like it, share it and subscribe to my channel. Thank you.